This question is asking us, an unstretched spring is slowly lifted from street level to the top of a tall building. Now, before reading more, remember when they are saying unstretched spring, if it is not stretched, if it is not compressed, then they are not talking of elastic potential energy. So the spring could have been a rock. As long we have elastic potential energy only if we stretch or compress something, and it's going to bounce back to its original shape. Now, lifted from street level to the top of a tall building, that's we are changing the height. Whenever we change the height, gravitational potential energy is involved. If you go up in height, like here, lifting, we increase the gravitational potential energy. If you go down in height, we decrease it. Then here the question says, compared to street level, the spring has more. There is nothing connected to elastic potential energy here, since the only thing involved is lifting that block of mass that's called a spring, that could have been a rock from street level to the height of the building. Now, when we lift, we increase the gravitational potential energy. So the answer here should be gravitational potential energy. Suppose you drop the spring from the top of the building and it falls towards the street below. Neglecting non-conservative forces such as air resistance. Now, if we ignore the effect of air resistance, what would the kinetic energy of the spring at the instant just before it hits the street? Now, obviously, the possible answers here are going to be the same as the gravitational potential energy at the top of the building, more or less. Now, if there are no lossy forces like air resistance, we should have conservation of energy, meaning the energy that the spring has at the top of the building should be the same as the energy it has at the bottom of the building. At the top of the building, it has gravitational potential energy and no kinetic energy because it's going to be dropped from there. So it has gravitational potential energy because it is at that height, and no kinetic energy because it is not thrown, it is just dropped. So at the bottom, it's going to have kinetic energy because it's moving, and no gravitational potential energy because it went back to the same level from where we lifted it. So it loses all that gravitational potential energy we gave it by lifting it to the top of the building. So it has kinetic energy, but no gravitational potential energy. The total energy at the top is just gravitational potential energy. We don't have any other type of energy. The total energy at the bottom is going to be just kinetic energy, since we don't have any other type of energy. But the total energy has to be the same. So the gravitational potential energy at the top should be the same as the kinetic energy at the bottom. And that should be the answer chosen here. Now, of course, if air resistance is present, then the kinetic energy, some of the gravitational potential energy at the top is going to go as thermal energy due to air resistance. Not all of it is going to turn into kinetic energy. And that's why the kinetic energy at the bottom is going to be less than the gravitational potential energy at the top of the building. Part of that gravitational potential energy turned into thermal energy due to air resistance. The other part is going to turn into kinetic energy.